Hello students, welcome to PUC College online classes. In the last video we have discussed IUPAC nomenclature of alcohol, phenols and ethers. Now continuation, structure of functional groups, and here I have written alcohols, phenols and methoxy ethers. Yeah. Now we have to see the first here bond angles. So you know that what is the hybridization of this oxygen in the alcohol is sp3, and here also sp3, because you already know how to calculate the hybridization. And here oxygen 2 bonds and 2 lone pairs, totally 4, so that's why sp3. And here also, and here bond pairs 2 and lone pairs 2, totally 4, so that's why it is also sp3 hybridized, and here also it is a sp3 hybridization. So whenever it is sp3 hybridization, so what should be the angle? Angle should be 109 degrees 28 minutes. This is the whenever any atom having sp3 hybridized carbon, the bond angle should be 109 degrees 28 minutes. But if you see here in the alcohols, simply methanol, the bond angle is less than 109.28 minutes. So what is the reason for that? Here, see here, on the oxygen we have 2 lone pairs. You know that lone pair repulsions are greater compared to the lone pair and bond pair. Yeah, so that's why here 2 lone pairs are there. They repel each other. It will move this side, and this lone pair move opposite side. When they move away from each other, they are coming close to bond pair electrons. Here bond means 2 electrons are there, and they are coming very close to bond pair. And then what will happen? Lone pair, bond pair repulsions will be there, and it is coming close to the bond pair. Bond pair, lone pair repulsions will be there. Due to that, to avoid that repulsions, these 2 bonds will come close to each other. Means this bond is there and comes close. When the bond coming close, the 2 bonds are coming close, then automatically what will happen? Bond angle decreases. That is the reason why in alcohol the bond angle is not 109 degrees 28 minutes. Yeah, simple. Lone pair repulsions. Due to the lone pair repulsion, these 2 lone pairs move away from each other. They are coming very close to bond pair. Then bond pair lone pair repulsions, and to avoid that bond pair lone pair repulsions, these 2 bonds move close to each other, and then automatically bond angle. The same thing happens here and here, almost the bond angles are equal. And coming to the ethers. In the ethers, the bond angle is greater than 109 degrees and 28 minutes. Actually, it is also this hybridization. sp3, I have already mentioned. But what is the bond angle here? And 117 degrees. Yeah? See, why it happens? And even though we have already discussed the same reason here, but along with that, we have here very bulkier groups. Ether means what it is? R and R. Alkyl groups, R it can be alkyl, phenyl groups, aryl groups also. And these are bulkier groups. When the bulkier groups are close to each other, and there will be a repulsions. Why repulsions? Because bulkier groups means what? This group means it is having bond pair electrons here. This molecule is having electron, and this molecule also having the electrons. And so that's why bulky, so that's why these 2 electrons, these 2 molecule groups electrons come close, then due to the same charge, electrons with same charge, they repel each other. When they repel each other, they move away from each other. So that's why automatically, previous like this, now they, due to the repulsions, they move away from each other. So automatically what will happen here? Bond angle increases. So that is the reason why in ethers the bond angle is greater than 109.28 minutes, that is exactly 117, because of the repulsions between the bulky groups of the alkynes. Yeah, so this is about the structure of functional, and also you see here the bond length between the carbon and oxygen is 142. Almost the bond length between the carbon and oxygen is 141. But you see in the phenol, it is quite less compared to the 142 and 142. Here the bond between the carbon and oxygen is 136 here. Why it happens? You already know. And here, this is lone pair electrons are there on the oxygen, and you know benzene means double bonds are there, and you know double bond and lone pair are separated by single bond. So it is a conjugation. When conjugation is there involved in the resonance, means this bond electrons will come here and single bond is converted into double bond. Means this CO bond is not a single bond. It is a partial double bond character it shows. So that's why single bond it is a partial double bond. So that's why automatically you know number of bonds increases, bond length will decreases. So that's why 136 ppm will be. So that's why this is about the structure of. Next one is preparation of alcohols. Till now what we have discussed, that is everything is basics. Now we are entering into the main topics of alcohol, phenols and ethers. Okay? The first one is here preparation of alcohols. Clear? And that I will not discuss much here, but we have already discussed some concepts in the haloalkanes and the halohalides. You know, alkyl halides react with the aqueous KOH. You will get the alcohols, and also alkyl halides react with moist Ag2O. We will get the alcohols. Clear? So one preparation I will simply write here from haloalkanes. From haloalkanes. This we have already discussed in the haloalkanes, but for simple again just I am recollecting. So from haloalkanes, you already know that haloalkanes when treated with aqueous KOH. Aqueous KOH. Previous I mentioned. Aqueous KOH means substitution reaction. Alcoholic KOH means elimination reaction. Clear? So that's why. And just heat it. And what you will get? And X is substituted by the OH. So you will get the compound is ROH plus and KX. ROH plus what you will get? KX. This is what it is. Alkyl halides, or you can write here haloalkane. And you are getting which one here? Alcohol. This we have already discussed it in the haloalkanes. Yeah? And second preparation is from alkenes. From alkenes. This is very, very important. Not much. It is not that much important for the PU, but very important for the compound. Clear? So next one is from alkanes. And here the first one is by acid catalyzed hydration. By acid catalyzed hydration. And mechanism also there in the NCERT textbook they have given mechanism. Mechanism also we have to discuss. Clear? So by acid catalyzed hydration. What is meant by hydration? Addition of water. Clear? That we will call it as a hydration. Take the alkene. I will take here simple alkene. Alkene means you already know. This is the alkene. Clear? And we have to add the which one? Hydration means what it is? Water. And here acid catalyzed, so that's why it is a H plus. Clear? And also this also we have discussed. And you know this in the first year you have studied already. Alkenes, addition of water. You know, and whenever we are adding anything to the alkene, and we have to follow the Markovnikov rule or anti-Markovnikov rule. Clear? But you know that it is a symmetrical alkane. It is symmetrical alkene. So that's why we need not to follow any Markovnikov rule or anti-Markovnikov. Anti-Markovnikov rule when we will use when peroxides are there. Clear? And this is simply add here H. Water how can we write? H plus and OH minus. Clear? And H will be added at one carbon double bonded carbon, and OH will be added at another double bonded carbon. Clear? Then what the compound you will get? you will get double bond. When addition reaction takes place, double bond is converted into single bond. And here H, and here you will get the compound is OH. Clear? So this is which one? This is alkene. This is alkene. This is what it is, alcohols. So we are preparing alcohols from which one? Alkene. By the what it is? Hydration in presence of acid capacity. And if I take suppose unsymmetrical alkene, CH3 and CH double bond CH2. This we will call as an unsymmetrical alkene. And now add the water in presence of H plus. Add the water in presence of H plus. Now we see it is unsymmetrical. Addition of water to the addition of anything, HBr or H2O, it follows the Marconic of food. And you already know what is the Marconic of food that we have already discussed in the haloalkanes and haloanes. So what is that one? According to the Marconic of rule, the negatively charged ion, water can be written as H plus and OH minus ion. The negatively charged ion and added to the double bonded carbon where the number of hydrogens are less. So negatively charged ion attached to the double bonded carbon where the number of hydrogens are less, and hydrogen will be added where the number of hydrogens are more. Yeah? Then what the compound you will get here? CH3, and you know COH, double bond is converted to single bond, and you will get the compound is CH. So this is how we will prepare the alcohols from alkene. But here mechanism is there. So mechanism also we have to discuss. And the answer is clearly they have given mechanism. So what is the mechanism here? Clear? So if you discuss about the mechanism, you know that it is we are adding acid to the water. When we add acid to the water, water is not in the form of H2O. It is in the form of hydronium ion. Because you know that H2O plus H, and it is electron deficient and it is electron rich, and it donates the electrons to H plus and making a bond. Oxygen is losing electron, acquires positive, and this is H plus is gaining electron. It acquires the negative, and positive and negative present on the same atom, charge will be neutralized. So that's why you will get H3O plus. This we will call as a hydronium ion. So whenever we are adding acid to the water, water is not in the form of H2O. It should be in the form of hydronium ion. Clear? Now, and the mechanism of here this addition of hydration, it involves mainly 3 steps. Involves mainly how many steps here? 3 steps. And the first step, step 1. Clear? First step, what will happen? Formation of carbocation. Formation of carbocation by the addition of water to what is alkene. So what happens you see? So I will take the simple alkene and the CH2 I will take, and CH2 double bond and CH2. Ethene I have taken here. Now, and I have to add the which one here? Water. Water is in the form of which one? Hydronium ion. This is the positive charge H, and the H on the oxygen there will be a positive charge. Clear? So you know that this is, and it gives the H plus ion. So that's why. And this is electron rich and this is electron deficient. It take the H plus, and these bond electrons will move towards the oxygen. Clear? Because alkenes involved in electrophilic addition reactions. So first electrophile should be added. From where you will get the electrophile? From the hydronium ion. Then what will happen? This carbon is losing electron, this carbon is gaining electron. This negative charge and here positive. Then there will be a bond. So you will get the compound is CH2 plus, and here CH2 and H means CH3 plus what will be removed here? Water. This is clear? Simple. And just transfer this bond to this carbon. Then what will happen? This is losing electron, this is a positive charge, and it is gaining electron, this is a negative charge. And this hydronium ion gives the H plus. H plus and minus and plus, it will be added here. That is what I have done. This we will call as a carbocation. This we will call as a carbocation. It is the intermediate in the hydration of alkenes. Clear? And second step, what is the step 2? In the step 2, you know, this carbocation, this is nucleophile H2O added attack on the carbocation. Clear? So here nucleophile attack, or simply you can write here H2O attack on carbocation. H2O attack on carbocation. And you see what is the step I can write here? CH3 CH2 plus here water. Water means H2O. Can I write it? This is, you know, positive means electron deficient, oxygen is electron rich. By donating electrons to the electron deficient, it make a bond. Then it is losing electron, positive charge you will get CH3 and CH2 and O H and here positive charge. Because oxygen is giving electron means losing electron means which charge? Positive charge. And it make a bond by donating the electrons. And this is the next step. And the last step here is step 3. In the step 3, deprotonation. Deprotonation to form alcohols. Deprotonation to form alcohols. And you know here CH3 and the CH2 and the H and the H. And you already know, whenever positive charge is present on highly electronegative atom, it is very unstable. So that's why oxygen try to gain the electrons from the hydrogen. So that's why here already water we have. So how it will lose? And water, it donate the electrons to hydrogen, and hydrogen will lose the electron. So that's why you will get the compound is CH3, CH2, OH. Because which one is gaining electrons? Oxygen. Oxygen is having which charge? Positive. And negative and positive charge will be neutralized. It will be H plus. So it is giving electrons here. So oxygen is losing electron. Then we will get a H3 plus. This is clear? So this is the mechanism of hydration of alkenes to form the alcohol. Formation of carbocation and water attack on carbocation, then deprotonation, and finally you are getting here alcohols. You are getting here alcohols from which one? Alkene. So what is the intermediate? This you have to remember. Carbocation is the intermediate. So next method is, we are discussing about preparation of alcohols. And first method we have discussed by acid catalyzed hydration of alkenes. Very important. What is the intermediate in this case? Carbocation is the intermediate. Whenever carbocation is intermediate, then there is a chance of rearrangement. After completion of this, I will give you one example, then we can understand. Whenever carbocation is intermediate, there is a chance of rearrangement, or sometimes ring expansion, sometimes there is a chance of ring contraction. So those I will not discuss, but one example that I will discuss. And here, next concept is hydroboration and oxidation. By using hydroboration and oxidation, can also be alcohols prepared. So how that is? Clear? And simple. I will take here unsymmetrical alkene. I will take unsymmetrical alkene. That is propene. When propene is treated with diborane. Propane is treated with which one here? First I will write the reaction, then step by step we will write. And what is here? First they will give diborane. Diborane means what it is? B2H6, or sometimes they will give monomer of diborane, that is BH3. And the second one they will give here, and here oxidation. Oxidation means with the hydrogen peroxide NaOH. NaOH. Yeah. So what is the final product you will get is, you will get the final product is CH3, CH2 and CH2OH. This is the final product. Clear? Unsymmetrical alkene, B2H6BH3 and CH2O2NaOH, and you know, see, you will get the alcohols. See how the reaction takes place. Clear? And first of all, and here CH3, CH double bond CH2, boron, you know, and here BH3. Clear? So now addition reaction takes place. Addition means what it is? Hydrogen should be added on one double bonded carbon, and the remaining part what it is? BH2 should be added at another one. So I will write that BH3 as a HBH2. Clear? So which one add at which double bonded carbon? That you have to identify here. You know that, and BH2 is a bigger group compared to the hydrogen. So that's why the BH2 will be added to the double bonded carbon, and where there is no steric effect. Steric effect means what it is? You know, where the number of hydrogens are more. If here we added, here which group is bulky group is there? So if BH3 added here, there will be a repulsions. So that's why where the number of alkyl groups are less, and to that carbon BH2 will be added. So then what the compound you will get is CH3, and here CH2. H will be added at more alkylated double bonded carbon, and here double bond is converted into single bond and BH2 will be added here. This reaction will not stop here. Why? Because this is like R group and BH2 is there. This BH2 can also provide another one H to the alkene. So that's why what will happen, you see. Same, it will react with the another alkene, that is CH2. This is the same one. So now what happened here? This gives the one hydrogen to this, and BH and this model will be added to CH2 group. Then what the compound you will get? CH3, and you know CH2 and CH2 BH. One hydrogen is added here. BH will be added here. BH and remaining group what is there? CH3, CH2, 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 CH3. Shall I write this one as a CH3, CH2, CH2 twice BH? This is same groups, so twice I have. And again the boron is having one hydrogen, so that's why it can again give the one hydrogen to alkene if I add. So that's why again I will add the same alkene here and CH2. Clear? Then what happened, you see? And this hydrogen will be added here, and boron will be added to the double bonded carbon. Then what the compound you will get? CH3, CH2, CH2B, and here CH2, CH2, CH3, and you know twice. Simply what I can write here, and CH3. This is also same group. CH3, CH2, CH2 thrice, and boron. Trialkyl boron. This is the one of the intermediate. Trialkyl boron. Now this trialkyl boron, this is the addition of PH3 to the alkene. When BH3 is added to the alkene, you will get the trialkyl boron. Now this is saying what is there? Which one here? Oxidation. Oxidation, what happens you see here? And trialkyl boron and CH2 and CH2 and boron I will write like this: CH2, CH2, CH3, and another one here CH2, CH2 and CH3. This we will call as a trialkyl boron. I mentioned here these groups as a alkyl groups. Yeah, trialkyl boron. Now we have to add the 3 moles of the hydrogen peroxide in presence of the basic medium. Clear? And hydrogen peroxide means what I can write here? OH and OH. And this bond will break. One OH will be added to this carbon, and another OH will be added to the boron. And here also, just for simplification, OH and OH, and here OH and OH. Finally, what you are getting, you see? CH3, CH2, CH2, OH. CH3, CH2, CH2, OH. And here also, you will get the 3 moles of CH3CH2 CH2 OH plus you are getting BOH thrice. Clear? So finally what you are getting, you see, this is a alcohol. This is what it is, alcohol. And here we can write this one as a H3 boric acid. Byproduct is what it is here, boric acid. So this is the hydration, hydroboration and oxidation. But whenever coming to the competitive examination, writing all these steps is difficult. So how to write the direct product here? And simple one trick, and you will get the final product in the hydroboration and oxidation. Just add the water to the alkene according to the antimonotonic of rule. Add the water to the alkene according to the antimonotonic of rule, then you will get the which one here? Alcohol. Yeah, simple. Suppose sometimes they will give compound like this, and they will give benzene, they will give, and here CH double bond CH2, and they will give here BH3, and second one is H2O2 and OH minus. Write the final product. Just what we have to do final product means add the water to this double bond carbon according to the which one? Antimonotonic of rule. According to the antimonotonic of rule, H plus and OH minus where it will be added? Where the number of hydrogens are more, and here it will be added where the number of hydrogens are less. So what the compound you will get? You will get the compound is CH2 OH. Just remember this one. Then you can easily write this if they give you the competitive examination. So this is addition of water according to the antimonotonic of rule to the alkene, then you will get the alcohol. That is the final product in the hydroboration and oxidation. So here by using this hydroboration and oxidation, mainly we will prepare the primary alcohols. And if they give terminal alkenes, and the major product, the mainly product is here primary alcohols. Yeah. So this is sometimes conversion it is useful. So they will give here, they will ask how to prepare the primary alcohols. Directly you can use the hydroboration and the oxidation. So we have completed hydroboration and oxidation. Remember one point here. In the hydroboration and oxidation, there is no intermediate. Like hydration of alkanes, carbocation is the intermediate. But in hydroboration and oxidation, there is no intermediate, and there is a just cyclic transition. 4-member cyclic transition will be there. That is not required here. So transition state will be there, but there is no intermediate formed in the hydroboration and oxidation. You just remember that point, very important. And the next one is oxymercuration and demercuration. Yeah. So what is this oxymercuration and demercuration? So what we will do, we will take the unsymmetrical alkenes, same like, and CH double bond CH2. Yeah. And first what we will do, we will add here mercuric acetate, HCOCH3. OCOCH3 we will call as acetate, mercuric acetate, and solvent we will take THF and water. And this is the first step. And second step, demercuration. Or sometimes here they can write reduction also. Reduction. Instead of demercuration, sometimes they will write reduction also. Oxymercuration, reduction can be say, and also oxymercuration and demercuration can also be called. So this is oxymercuration, demercuration. THF, and second one is here reduction by using the sodium borohydride. Yeah. So what the compound you will get here? Alcohols. We are preparing alkenes from alcohols. So it is a CH3 and CHOH and here CH. Yeah. So what happened here? How these alcohols are prepared from the alkene by the mercuration? First, you get mercuration product, and after then reduction. How it happens? See now, CH3 and CH double bond and CH2 plus here HCO COCH3. OAC can also be written here and OCOCH3. Here, first you will get here one complex. Okay, so first of all, just assume, and it is attacking here alkane. You know, electron rich. You know here metals. It is attached to OCH3 and OCH3. So electron deficient, highly electron negative atoms are attached to the Hg. So that's why, and OCH3 will be removed. And you will get here partial double bond, here partial positive charge, and here there will be a partial negative charge, and it will be added. Then we see the how you have to write. And here CH and here CH to this will be added mercury, and here OCOCH. Now you see in this case what is how the transition state you have to write. Complex, not transition. You can see it is making bond with the Hg, that we can write here making bond with the Hg. And here the charge is coming here partial positive charge, and here the charge partial negative charge. And this partial positive charge is attracted by, you know, Hg. It is attracted. So that's why there will be a, this is the transition. Hg, you know, it is a metal. Metal means, you know, it gives the electrons to CH. Metals are electropositive. They can easily donate the electrons. So here the charge is there, here positive charge. So that's why it try to give the electrons to make a bond. So that's why it is a bond. This will be called as complex, or you can simply say transitions. Yeah. Then what happened next time? In the next time, and here what solvent is added. What is the solvent here? Water. H2O. H2O, you know, it is a electron rich. Which one is electron deficient? This is electron deficient. So that's why attack takes place here. This bond will break. Okay? You see, first of all, it is making, this carbon is making bond. So transition state you write. The bond we will not write here. So here there will be a bond break. So this is partial bond, and here positive charge is there, and it is a metal. Metal means what it will do? It will try to give the electrons to the electron deficient center, then making a partial bond, and double bond will be converted into single bond. When it is added, this bond, and it is giving electrons to carbon means it acquires which charge? Positive charge. So that's why when the attack takes place, this bond electrons move towards this, and positive charge will be neutralized. So then what the compound you will get to see? CH3 and here CH, and OH will be added, and H2 plus, shall I write here, H and H. Clear? Then what it is there? CH, HG, OCOCH. And the addition is one is added below the plane and another one is added above the plane. So now what happened, you know? So this is, which one is removed here? CH3 COO minus is removed. And here, you know, oxygen having the positive charge means very, very unstable. So that's why it takes the electron from the hydrogen and gives the H plus ion. So that's why what happened, you see, you will get the CH3 and the COH and H plus and the CH3CO minus will be combined and form the acetic acid, CH3COOH. And here CH and HCOCOCH. This is what we call mercuration product. Mercuration product means which one is added here? Mercury is added, so that's why we will call it as a mercuration product. And last part we have to do reduction. Reduction by using which one? Sodium borohydride. It provides the hydrogen hydride ion. It provides, you can write here, sodium borohydride, H minus, and here Na plus, and this attack here, and it will be removed. Then what the compound you are getting? CH3. You are getting this. Final compound is CH3, CHOH, and CH. This is what it is? Alcohol. So which alcohol we are getting here? Secondary alcohol. Means you see so much means mechanism is very lengthy. So that's why in the competitive examination we cannot write this much lengthy products. So directly you have by seeing this you have to write the product. So how to write the product here? This is for competitive. NEET or you can say mains. Most of the time this type of questions they are asking. Directly see this is CH3, CH and CH2. What is the final product you are getting? CH3, CH4H and CH3. How the products look like? Addition of water to the alkene according to the which rule here? Markovnikov rule. Add the water to the unsymmetrical alkene according to the Markovnikov rule. You will get the compound. According to the Markovnikov rule, you know, negatively charged ion attacked at the double bonded carbon where the number of hydrogens are less. You will get here OH and CH3. So that's why whenever they give the product like this, means reagents like this, OAC and water, and second time it is a reduction sodium borohydride. Just don't do all these things. Just add the water to the alkene according to the Markovnikov rule. That is the final product from the oxymercuration and demercuration. And also there is no intermediate formed in this oxymercuration and demercuration. There is no intermediate. In the hydroboration oxidation and oxymercuration and reduction, intermediates are not found. Only cyclic transition states. That is, we can say complex here, a cyclic transition state. Okay. So next one here, preparation of alcohols from the alkenes, and the three preparations we put it together here. See how to write. Yeah. And first I will discuss these two. You know, alkene H2B6 means diborane, and this is hydroboration and oxidation. So what is the final product? I already mentioned. So what you have to do? Add the water according to the anti-Markovnikov rule. That is the product. Yeah. Add the water according to the anti-Markovnikov rule. Anti-Markovnikov rule means, and here OH will be added. Negatively charged ion will be added. Double bonded carbon where the number of hydrogens are more. This is next one. Oxymercuration and demercuration. So oxymercuration means you see in the mechanism previous video mentioned, and Hg is added at one time. Demercuration means when we add the reductant sodium borohydride reduction, mercury will be removed. That is demercuration. So how to write the final product here? So add the water according to the Markovnikov rule. That is the final product in the oxymercuration and demercuration. So add the water here, CH3 and H, CHOH and CH3. This is the product. Clear? But we see here. Here what is the first one? Preparation of alcohol from by the acid catalyzed hydration. What do we have here? So what is the product we will expect? And we will just addition of water according to the here alkene is there, water is there. So what is the product we will expect here? Simply addition of water and unsymmetrical alkane. So that's why it is a Markovnikov rule. We will write this. So this is not the major product here. In this two okay, but here we will expect this is the product, but it is not the major product, and this is the minor product. So what is the major product? That we have to discuss. Yeah? Because I already mentioned hydration in the acidic medium to the alkane, and here what is the intermediate? Carbocation. When carbocation is the intermediate, then there is a chance of reaction. See how to write this one. So CH3 and here CH3H and CH double bond CH2. Yeah. First, which one will be added here? H plus. H plus where it added? To this carbon or this carbon? If added to this carbon, positive charge will get here. Secondary carbocation more stable. If H is added here, you will get the primary carbocation less stable. So that's why H will be added to this carbon. So H will be added to and first carbon, that is CH3 you will get CH3 and here this is. It will be added C plus and you will get the CH. Yeah, it is which carbocation? Secondary carbocation. It is a secondary carbocation because to the positive charge of carbon, two carbons are attached here. Secondary carbon. You know, whenever carbocation intermediate, if there is a chance rearrangement takes place to get the more stable carbocation than the secondary. What is the more stable carbocation than the secondary tertiary? Is there any chance here? Yes, you see here. In this one, there will be a hydrogen. This we have already discussed in the halocides and alkynes. What happened? This hydride shift takes place. This is the secondary carbocation, and the hydride ion will be shifted to this carbon to this. Then what the compound you will get? You will get CH3, positive charge here, and the hydride ion means what? H minus. Carbon is having the charge, positive and negative, there will be a bond. So you will get the CH2 and here CH3. What is that carbon? Which carbocation here? Tertiary. To this carbon, 1, 2, 3 carbons are added. It is a tertiary carbocation. So that's why this is more stable than the secondary. So that's why this we will call as 1,2 hydride shift. 1,2 hydride shift. Clear it is? So hydride is shifted to the, and this is 1 and this is 2. Positive charge in carbon we will consider 1 and this is 2. And it is shift takes place between the 1 and 2 carbon. So 1 to shift. And now what happened here? What will be added? So what is here? H2O. H2O means lone pair of electron deficient this is, and it is electron rich. Then you will get the compound is CH3, and O oxygen is losing electron, so it is having the charge, positive charge, and here CH2 and CH3. And now oxygen positive charge, unstable, so take the electron from the which one? Hydrogen. Then you will get the final product is CH3, and you will get here OH and CH2, CH3. This is the major product formed here. Clear? So this is minor. What is the major product you are getting? CH3, OH and CH2, CH3. So that's why you have to be careful when they have given the hydration H2O in H plus, because there is a carbocation intermediate in this reaction. So you have to identify whether there is a chance of rearrangement or not. When rearrangement takes place, it is secondary. If more stable carbocation is there, then rearrangement takes place. So you will get the major product is this. Next, third one is preparation of alcohols from the carbonyl compounds. Okay? So how to prepare the alcohols from the carbonyl compounds? You know what is the carbonyl compound? What is the carbonyl group? C double bond O group we will consider it as a carbonyl group. Clear? Carbonyl group means here there will be aldehydes or ketones. If both the groups attached to the CO are alkyl, that we will call as a ketone. This is a which one here? Ketone. If there will be a one hydrogen and one alkyl, then it is a aldehyde. It is a which one? Aldehyde. If both are alkyl groups, clear? This we will call it as a ketone. This called as a ketone. Clear? If you do the reduction, by using reducing agents here, we have so many reducing agents. So I will discuss what are those. We have to reduce by using the reducing agents. Take the reducing agents. Then what will happen? Aldehydes are converted into alcohols, primary alcohols. Aldehydes are converted into which alcohols here? Primary alcohols. Here and same way, in the same way. And use the reducing agent. Use the reducing agent here. And ketones are reduced to secondary alcohols. Ketones are reduced to which alcohol here? Secondary alcohols. So what are the reducing agents here? We have so many reducing agents, and here you know hydrogen metal. Take the platinum metal means what we can take here. Platinum, palladium, nickel, all these are, you know, hydrogen absorbed on the metal will be a very, very powerful reducing agent. We can use that one also. And the second one, this is one reducing agent. And the second one, you can use sodium in ethanol. This is also one reducing agent. And third one, third one is, you know, lithium aluminum hydride. LiAlH. This simply we will call LaH. Powerful reducing agent. And the fourth one is here sodium borohydride. This is also. See, these all are powerful reducing. These all are reducing agents, and these reducing agents reduces the aldehydes to alcohols, primary alcohols, ketones to secondary alcohols. If I take the simple example here, suppose I will take acetaldehyde, CH3CH4. This is acetaldehyde. Yeah. If I use here H2 and palladium, H2 and palladium. Yeah. This is aldehyde. Aldehydes are reduced to which one? Alcohols. So CH3, CH2OH. Which alcohol here? Primary alcohol. You know OH is attached to CH2 group. That alcohol we will call as a primary alcohol. If I take ketone here, CH3, C double bond O, CH3, ketone. If I take suppose any agent you can take, lithium aluminum hydride or sodium borohydride you can use. Suppose if I take lithium aluminum hydride and followed by the hydrolysis water, then what the compound you will get? Ketones. Ketones are reduced into which one? And here it's simple. What they do here, they provide the hydrogens. Add one hydrogens to the carbon and another hydrogens to the oxygen. Then what happened? Double bond. When reaction takes place, double bond is converted to single bond. That is only the product here. See, one hydrogen added here, it is become CH2, and double bond is converted to single bond, and one H will be added to oxygen OH. Same here also. Yeah, just for understanding purpose I am saying they produce here hydrogens. Yeah. So that is the reduction. Addition of hydrogens, what we will call reduction. So this is the reduction of carbonyl compounds. We can call what is this one? Reduction. We can also say reduction here. Reduction means what they provide? They provide the hydrogen atoms. Yeah. So that's why you also see, and one H you add here, and another H add the oxygen, and convert the double bond into single bond. You will get the which one here? All are these reducing agents. Reducing agents, what they will do? They convert the carbonyl group into CH-OH group. That is the. So this is the another preparation for alcohols from the carbonyl. So next preparation of alcohols are from the reduction of carboxylic acids and esters. Yeah. So what we have to do, take the carboxylic acid. I will take the carboxylic acid, general formula I will take RCOOH. And the best reagent for the conversion of acids into alcohol is, we have to do reduction. Reduction means what we have to do? It provides the hydrogen atoms and acids are converted into alcohols. So this is lithium aluminum hydride and followed by water. The same question one time they have asked in the PU examination for 1 mark. They have given and here acid and converted it into alcohol. What is the reagent they asked? So which reagent we have to use here? Lithium aluminum hydride. Here also reduction. So reducing agents I have mentioned so many, but you should not use here sodium borohydride. Sodium borohydride cannot reduce the acids into alcohols. Acids into alcohol. Only which one here? Lithium aluminum hydride and diboron also, but that we will not discuss here. I will give you one table. There you can easily understand which reduces acids into alcohol. Okay? This is, suppose if I take here CH3COOH and then and lithium aluminum hydride, powerful reducing agent it is, followed by hydrolysis. You will get the compound is CH3CH2OH. Simple. Remember one process here, PHENOLS process. For understand, just for remember. And you. A means here alcohol. A means what is alcohol, and this is A means aldehyde, and this is a acid. Clear? If you do the oxidation, alcohol oxidation, you will get the aldehydes. Aldehyde oxidation, you will get the acids. Reverse process is there. If you take the powerful oxidizing agent, alcohols are directly converted into acids. If you take the powerful oxidizing agent, alcohols are directly converted into acids. Weak oxidizing agent, if you take, alcohol must convert into aldehyde. If you use another oxidizing agent, it will be converted into acid. Same here, acids, if you do the reduction, you will get the aldehydes. Aldehyde further reduction, you will get the, what it is here, alcohol. If you use powerful reducing agent, then directly acids are converted into alcohol. If you use the powerful reducing agent, acids are directly converted into alcohol. It will not stop at the aldehyde stage. Directly converted into alcohol. That is only here you see. It is lithium aluminum hydride, powerful reducing agent. It reduces the acids into which one? Alcohol, because it is a powerful, that is CH3COOH, lithium aluminum hydride, CH3CH2OH. Yeah? And second one is esters. You know that what is the ester formula? RCOOR. This is the ester. If you do the reduction by using lithium aluminum hydride and followed by hydrolysis, you will get the two types of alcohols. You will get the which one? Two types of alcohols. Simple. And here bond you break. It provides the hydrogen. Just H2, it is mechanism is not exactly correct, but for how to write the products I am saying. And put H and H here. Then what you are getting? R-OH. This is one alcohol. And here which one is there? Aldehydes. Aldehydes are there. Lithium aluminum hydride is powerful reducing agent. It converted into which one? Alcohol. So that's why this is also converted into which one? Alcohol, CH2OH. You will get the mixture of alcohols. One is RCH2OH and another one is alcohols. Yeah? And if I take suppose simple example, CH3, C double bond O and O, C2H5, and do the lithium aluminum hydride and followed by water. Then what will happen? This will be converted into alcohol, one alcohol, C2H5OH plus. It will be actually H and H if you add. It is alcohol, it is aldehyde, but aldehydes are, it is powerful reducing agent, it reduces further to which one? Alcohol. So it will be converted into another alcohol, CH3, CH2OH. You see, in all cases, we are preparing which one? Alcohol. By which process? A reduction. So reduction of acids and esters, you will get the which compounds here? Alcohols as a final product. But in the ester, you will get the mixture of alcohols by the reduction of lithium aluminum hydride. So here, reducing agents I have written, 4 reducing agents. Very important these reducing agents for the competitive examination also. Yeah. So one question they have asked in the last JEE mains examination from this table. I will give what the compounds, exact not the compound. So I will give. So here H2M means hydrogen atoms on the metals. Like you know hydrogen, platinum, palladium and nickel. It is a powerful reducing agent. It reduces all the functional groups. Aldehydes, ketones, acids, ester and acid chlorides, anhydride, double bond into single bond, NO2 into NH. See, it reduces all the compounds into respective. Aldehydes are alcohol, ketones, secondary alcohol, acids, alcohol, and 2 types of alcohol. This is also converted into alcohol. This is acid chloride. Ester, acid chloride, acid anhydride. All are converted to alcohol. Double bond is converted to single bond. NO2 is converted to NH2. But if you go for lithium aluminum hydride, you know lithium aluminum hydride just now we have discussed. Aldehydes are converted into alcohol. Ketones are converted into secondary alcohols. Acids are converted into alcohol. A powerful reducing agent, acids are converted into alcohol. Esters also converted into mixture of alcohols. Acid chloride, acid anhydride, these all are converted into, means it indicates that lithium aluminum hydride is also a powerful reducing agent, but compared to hydrogen and metal, it is somewhat less. It cannot reduce the double bonds. And also NO2 group, it cannot reduce double bond and NO2 group. If you take the sodium borohydride, it is a very selective reducing agent. It reduces only aldehydes into primary alcohols, ketones into secondary alcohols. Remaining acids, esters, acid chlorides, anhydrides, double bond, it never affect. Clear? Last one is diborane in presence of PHF. It is also somewhat powerful compared to the sodium borohydride, but less powerful than the lithium aluminum hydride. Clear? See now. And it is same. Alcohols, aldehydes are converted into alcohols, and it will be converted, but it won't reduce the acid chlorides into alcohol. And remaining all acid, esters, and anhydrides will be converted into alcohols, but it will not reduce the acid chlorides into alcohol. And also double bond and the NO2 group also will not affect. And one question, mains examination they have given question like this. It is not the exact question, but roughly I am writing. And here NO2 they have given, and they mention here somewhere COOH. So they have mentioned here compound also. So same compound here NO2 is present, and here CH2OH. Options they have given. One is B2H6 PHF, sodium borohydride, lithium aluminum hydride, and H2O. These are 4 options they have given. Which one you have to select? Acid are converted into which one? Alcohol. Acid are converted into alcohol means lithium aluminum hydride and B2H6 also can reduce the acids into alcohols. But you see here NO2 group is present here. In the compound also NO2 group. NO2 group is not changed. NO2 group is not changed. Okay? See in this case. If you see lithium aluminum hydride, and lithium aluminum hydride, so this is, it converts the NO2 into NH2. It converts the what it is? NO2 into NH2. I made a mistake here. It converts the NO2 into NH2, but it will not convert the double bond into single bond. And double bond is present here, double bond is present here. Lithium aluminum hydride we can use, and the acid is converted into alcohol means we can use the lithium aluminum hydride, and B2H6 also we can use. But here you see NO2 group is not affected. Means if you use lithium aluminum hydride here, acid is converted into alcohol, and NO2 is converted into which group? NH2. So that's why you should not use lithium aluminum hydride. You have to use the next compound here. B2H6 and PHF is the suitable solvent, suitable reducing agent for this transformation. So, like these questions will come from this table, very important table for the company.